So very good evening, everyone, and I welcome you to this session today in which we will go through the practical aspects of STEM, robotics, and AI into our classroom program. Specifically, if we talk in terms of STEM, robotics, and AI, it is designed for class 9 and 10 students as per the board members of different background like the ICSE boards and CBSE board in India, as well as the state boards, those who are following the Atal Tinkering Lab, and so on. So those teams can accommodate these learning in their classroom programs, as well as we are not limited by class 9 and 10, but yes, many schools are nowadays offering the classes for STEM to different junior classrooms. They are starting these sessions for class 5, from class 5 to the above. So it will be helpful for you to cope up with the same. So in today's session, we will discuss in details about the embedded C++ programming, which is very crucial for you teachers as a teacher point of view. So because as we all know that not the embedded C, but C programming language is mother of all the programming languages we do have with us. And why to consider the C programming language for to interact with different hardware device and something like that? Because embedded or the term C itself helps, or like majority of the platforms have been developed because of the embedded the C programming. And in computer also we use one kind of programming, that is C programming, but it is comparatively different compared to the conventional C programming. Means whenever we talk in terms of C programming, we are talking about the development of user interface. I believe you are learning the Python through our classroom program as well, in which you are seeing those response in the screen itself, right? There is no practical implementation of those codes to actually actuate something to produce motion or to like replicate some of the tasks in our general environment. So basically, if we talk in terms of programming, means we are talking about a conventional type of programming in which we are developing the user interface, in which every user have to like submit some of the input data to further process it using the logic and produce the output in the platform itself. But embedded C or embedded C++ or the Python for the hardwares are completely different in terms of the execution. Execution means we are talking about the exact scenario where we have to like control those hardware parts using the software and other devices. So if we are controlling the hardware components or the hardware counterpart using the programming done in embedded platforms or embedded C++ platforms or Python itself, then we are talking about some of the embedded development. And by the term embedded means we are talking about some of the hardware devices in which we can able to implement the automation stuff, automation with to automate certain process in our premise as well as in required place. So that is why I'm going to cover the topic today, the embedded itself, and further we will see some of the key concept uh, to utilize in our like different key components like the open source platform. We already seen some of the greatest older open source platform for our application into the STEM education. So why to use these open source platforms? Because open source platforms gives us the ability to utilize their tools and different application without paying anything. That is free for innovators, mentors, and teachers around the world. So that is why the open source platform are too much important for all of us. Even though students can sign up to this portal and they can utilize to build different design different 3D models for further 3D printings and rapid prototyping, and also they can go through the simulation part of Tinkercad platform to like simulate those circuitry beforehand going for the practical approach, like doing those things by hand or manually. So the need of these simulation is because if we talk in terms of different microcontrollers, if we talk about different microcontroller, and you will know that different microcontroller does have prices, right? The Raspberry Pi comes around like 4,500 Indian rupees or something like that. So you have to invest, and during the time of experimentation, suppose if you by mistake connected the positive and negative terminals together, and your chipset or the board burned in between, then what you will do? So you have to buy a new one. So to prevent that thing happening in our classroom programs, we must take care those things beforehand. Means first, we have to encourage our student to go for these open source platform, and like help them to like complete their get their concept and understand the basic concept of these programming languages and the practical onboards setup as well. Then only you should allow your students to like cope up with the practical hands-on session directly with the boards and other electronic devices. So in earlier classes, the last classes we covered the topic of introductory part of robotic system, and further we understood the concept of like law of robotics, and also we went through the AC and DC stuff, analog and digital stuff, and also discuss the AC current and DC current in detail. So introduction of basic robotics for a student has been done, and components to build robotic system were explained properly in this session. So in day two session, what we are going to have is a complete guidance for C programming or the embedded programmings for different boards, not limited to the Arduino counterpart, because we should not limit ourselves with the Arduino platform, as Arduino platform is not fully free. We often hear from the peoples around the world that Arduino platform is completely free and we can utilize. But if you go for the IoT application and utilize their IoT platform, then there is some prices are involved, which is, yes, very crucial for the company to run their own things, right? Because without the business, they won't survive in the market. So if you look closely here, I'm showing you one of the picture of the Arduino board, that is Arduino Nano. And if we talk about the Arduino itself, as I mentioned earlier, whenever we talk about this particular word Arduino or something like that, means we are talking about the development boards. Development boards means those boards which does have microcontroller embedded into it, and on that microcontroller, we can actually program the microcontroller to take the inputs from the sensor devices, and also based on the logical outcomes, we can produce any of the outputs to any of the pins. So each and every microcontroller will have the common things in between, right? The common things means we are talking about the IO pins. IO stands for the input and output pins. So input slash output pins. So these things you will find common in each and every development board. And I personally do not call this like it is, yes, it is not the microcontroller in total, but the development board. And in development board, the microcontroller is located in here, like this. In Arduino Nano, the microcontroller is located in here, and the particular model number of microcontroller we are using is Atmega 328 MCU or P variant or U variant. There are different type of variant present in the market. So you can find the chipset as well to like accommodate it in your project directly without using or utilizing any of the development board in between. But yes, for the learning perspective, we can go for the development board. You can buy one and like help yourself doing the program and seeing the response in the terminal windows as well as in physical output devices. So if you look closely to this picture, you will find one mini USB port is properly placed in there. So mini USB port is useful to like further communicate with the computer device. Like this is mostly the required one for the communication between the computer or the system or with the microcontroller stuff. So each and every microcontroller does have a reset button. You can see I'm circling it on a green. So these reset button is actually helping us to like reboot the program or reboot the entire system to read the program from the line one. And that is very important because sometimes, because we cannot able to predict the outcome of the like a programmed device, sometimes it malfunctions or sometimes it will behave differently because of the environment condition, because of the temperature it is exposed in, and so many other aspects to consider. So these reset buttons comes handy to reset the entire program. Means the time when we press the reset button, it will execute the code from line one, from again and again, the time when we'll press it. So what it will help us with to reset the program to initial base. So we do have different LEDs as well mounted on boards. So LEDs, as I explained earlier, that some of the LEDs were also mounted on the Arduino Uno board, which I'm going to show you in a minute. So the LEDs are the RX LEDs, the TX LEDs, the PWR LED, and D13 LED. So the Arduino board does have one inbuilt feature, that is one of the LED is directly connected to pin number 13. Pin number 13. So we call this LED as onboard LED. And even though if we do not have any of the input or output device with us, like the LED buzzer and so many other stuff, we can directly test our board using this particular LED by giving the output function to the pin number 13, and it will further help us to see the program in action. So basically, most of the time when we start with is the blink program, very easy to do, and also each and every programmer, like we often go for the concept of printing hello world in different programming languages, right? So in Arduino, basically we start with the blinking program. So LED blink is the common program to be utilized for the first time or the first timer who are like going for the same. So apart from these LEDs, the RX one is for receiving protocol and TX one is for the transmission protocol. And why to have these receiving protocol LEDs and transmission protocol LEDs? Because the time we are communicating with our microcontroller, so what we are actually doing, we are trying to upload some of the codes to the board itself, right? So the time when we upload some of the codes means board is actually receiving the communication from the computer. So the RX LED will glow. And further, when board is trying to make connection with the computer by to provide us the feedback or the data output in form of serial print function or the printf function, as we seen in different programming languages. So this TX LED will glow further. It is only to represent whether the communication is happening between the devices or not. That's that much only. So the power LED signifies the current situation of whether the board is receiving power from the USB mini USB port or from other places. Like other places, what is like something is like V in pin. So we do have V in pin in here to provide the power separately apart from the mini USB port. So whenever we are connecting the board to our computer directly, then yes, board is getting power from the mini B USB type of port. But yes, apart from after completion of our programming, the time when we have to like give the power functionality to our board, then we will utilize the V in pin. And V in pin can take up to 7 volt to 12 volt. This one is the recommended voltage for the VN pin. Even though we can able to provide 5 volt to the VN pin, but 7 volt to 12 volt is the recommended voltage for the VN pin. So that thing you should consider while like going for the same connection or all. So GND in every board will represent the ground option, and ground is nothing but the negative terminal of our battery or our the power source. So if we are considering, we have to consider the VIN pin as positive ones. So GND will represent the negative ones for the same. So apart from this, we do have separate 5 volt pin and the reset button pin. The reset pin is actually connected with this particular button, the reset button in mid between, so that if suppose if you built any of the project and in which you cannot able to like go and directly click on the reset button with your hand, then what you will do, you will take out the reset pin, the wire from the reset pin, and further connect the button, one of the wire of button to the reset pin and second wire to the ground, so that you can able to manually place your reset button anywhere into the project casing. So it will be handy for you guys to take care of these things. So apart from the pins, different pins, the IO pins is used for input and output. So 2 to 12 we do have IO pins in here. And also these pins are specifically known as the digital IO pins. Digital IO pins means we discussed earlier like two of the terms. First one was the analog system and second one was the digital system. So whenever we talk in terms of digital system, means we are talking about two of the values, 0 and 1. And whenever we discuss in details with respect to the analog system, means we are talking about a range between 0 and 1s. Okay, so these pins will further help the Arduino to like process the data based on the input. So why we require the digital pin? To simply turn on and turn off the circuitry. And why we need to have the analog pin? To simply play in between the values of 0 and 1. Suppose if we have to provide the low values, so what we will do, we will send the 0.5 in between. So to do that, we do have the ADC concept, which I will explain in the programming environment, the analog to digital converter to process the same. So apart from the digital IO pins, what we do have is the analog input pins. So analog input pins are crucial for different sensors, as some of the sensors do not operate with the digital environment, because if we have to take the reading of temperature, then we must take care of those temperature reading using the analog input pins. Otherwise, because the temperature is variable, right? So those things we are coming as a variable, we should consider using the analog input pins in between for the same. So after that, what we do have is 3.3 volt pin and analog reference pin. So I will explain the analog reference pin later on, but 3.3 volt is also very crucial for us, as different output devices which comes along with the Arduino, or we can buy separately from the market, does require 3.3 volt to operate. As I mentioned earlier in my classroom program, to run the microcontroller or to turn on the microcontroller, there is two specific voltage limitation. That is, some of the microcontroller works with 5 volt and some of the microcontroller does require only 3.3 volt to operate. Okay. And here on the top side, what we do have is the TX pin and RX pin. Suppose, because we know the limitation of our Arduino programming, Arduino boards, right? So Arduino board does have limitation. It does not have any connectivity option apart from the USB cable to do the direct serial communication between the computer and the microcontroller. But if we have to accommodate the Bluetooth connectivity or GSM module or something like that, then we have to utilize this TX and RX pin for the same to provide the data coming from the sensor itself. Suppose if we are going to integrate the Bluetooth module to give the connectivity option to the board, then we must connect the Bluetooth module to the TX pin and the RX pin for the same communication. And apart from this GND, we do have other GND as well. Both serves as the same purpose. There is no difference between this GND and this GND on the bottom. Okay, those pins are the same pins. But the reason why to have more than one GND pin is because we are not going to limit ourselves using only one device along with the microcontroller, right? So the time when we have to accommodate more devices compared to the one value, then we should utilize the GND pins which are readily available, more than one in any of the board. Any of the board means not limited to Arduino. Each and every board, the Raspberry Pi or the Node MCU, the ESP8266 board or ESP32 boards does have the GND pins more than two. So this is all about the Arduino Nano. And if we scroll down in this page, you will find one more microcontroller in this picture, right? So the reason why I'm covering this microcontroller, but because you have to understand the exact ideology to be followed in your classroom program, because sometimes there is no need to have the connectivity option to operate or like run the car, normal IR based line following car or something like that. You don't have to like accommodate with the connectivity option. But sometimes while building the IoT devices or other projects, you need to have those connectivity option in handy, right? So Node MCU is one of the development board, I can say, which is very good in nature, as well as it does have like connectivity option inbuilt into it. So Node MCU utilizes the microcontroller ESP8266 microcontrollers. So this particular chip you can see in the mid between is the ESP8266 microchip inside of it. And also this microchip does have one benefit over the Arduino. That is, the Wi-Fi connectivity option. So we will get the free Wi-Fi connectivity option in this microcontroller, and I believe this comes around 240 rupees or 250 rupees in the normal market to purchase from. So you don't have to buy the Arduino Nano or the Arduino Uno if you are going to integrate some of the connectivity option into the microcontroller, because it will cost you more than the requirement. So you choose the microcontroller wisely, based on your requirements or based on your project you are working with. So ESP8266 or the Node MCU, the Node MCU is the name of this development board, and ESP8266 is the microcontroller embedded into it. So Node MCU does have like a great functionality over the Arduino microcontroller because of, first, the Wi-Fi connectivity, and second, the data it processes. Means it can store the data, it can store more data compared to the Arduino Nano. If you go through the specification sheet, then you will understand what I'm trying to explain. Okay, so apart from the Arduinos, we do have A pins and D pins in Arduino. A stands for the analog pins or analog input pins, and D stands for the digital pins, whether digitally it is going to take the input or the output. D stands for the same. But in Node MCU or the other microcontroller, what we do have is the GPIOs, general purpose input and output pins. So GPIO pins can be addressed using the numbers. So suppose if we have to address the D0 pin in our programming, what we will use? We will use the value 16 for this particular pin. So if we have to address the D2 pin, then what we will do? We will address it using the 04 or normally the 4 in our programming. Remember last time we done the programming, sample programming, in which we declared the pin mode under the setup. So under the pin mode, we always declare the pin numbers like 4 or 5 or something like that, based on the input and output condition. So in place of this 4, what we will do, we will utilize the 16 or 4 or any other pins mentioned in the specification sheet rather than the D4. Because if we write down the 4, then it won't work for the D4, because for the D4 what we do have is GPIO 02. So we have to write down 02 to activate this particular pin. Otherwise you can write down D4 or D3 to directly address those pins available in your microcontroller. So apart from this, we do have different pins as well, like the MISO, MOSI, and CLK. CLK stands for the clock, which I will explain to you in future classes, the time when we will communicate with other hardware devices using this pin. Because suppose if we are going to integrate 8 LEDs into our project using the Node MCU, then yes, the 8 of the pins are available. But if we have to like accommodate 16 LEDs or 20 LEDs into our project, then we cannot able to utilize one microcontroller to address all of the LEDs, because we do have limited number of pins for the input and output control, right? So what we have to do on that case, we do have different SDA pins and SCL pins. SCL pins, that is the clock and data pins. So we are going to address those 16 LEDs or 64 LEDs using the method known as I2C, IIC or I2C protocol. We are going to utilize in future projects so that we can address 100 of hardware connected to single microcontroller. You don't have to buy a new microcontroller to accommodate other hardware devices or the input or output devices. We can do it in single microcontroller. Just we have to give them a physical address. Like you already seen some of the application of utilizing the Wi-Fi network or something like that. We always get the IP address to IP address for the identification of our system connected to the network, right? Similarly, we do have I2C protocol in the programming itself or the hardware itself to address individual hardware connected in same connection, connected with same wire, to address different hardware in between. So we will utilize those things in future programming lessons. So I hope the Node MCU is clear. And yes, the Node MCU board can be powered using the micro USB, uh, and we do have 2 inbuilt buttons in the Node MCU or the ESP8266 board. That is One button is to flash the board, and second button is to reset the board, or RST pin. So reset means, as you all know, reset means we are resetting the entire program again to execute it from the line one, means we are refreshing the memories, that's all. And flashing means the time when we click on flash, then only it will allow the computer to upload the program into the board. We can call it as like defense system for this microcontroller, or this is one of the good function available in the board itself. But one thing you won't find in the node MCU board, that is the 5-volt pin, because there is no regulator present to convert the voltage to 5 volt. We will always find 3.3 volt pin. One is here, second is here, and third one is here. Three of the 3.3 volt pin are there in the node MCU board, but you won't find any 5-volt pins because there are no regulators present in on board to convert the voltage to 5 volt. We can take the voltage V in pin as into our consideration to take any of the input or output voltage in this regards. But I will help you further to build one of the circuitry to process your own 5 volt for other devices. The time you will utilize more than one servo motor along with the microcontroller, you will see the power surge or the difficulties. See, many teachers and many peoples will only show you the positive part, but no one will show you the negative part of utilizing these all stuff, right? So negative part is when we try to overload our board in terms of power consumptions, the board will start rebooting again and again, means it will automatically switch off and switch on again and again. And that time you will be dumbfounded to understand what is happening with your board. So we have to make one separate power device for individual input and output devices to be connected into our microcontroller. We will only utilize the input and output pins for the same, but to power up those devices we will use separate power source for our uses. Otherwise it will contradict with the statement of power consumptions in between. Okay, so the most famous one is the Arduino boards, right? So unlike other microcontroller, it does have Arduino is the development board itself, right? And here we do have one of the microcontroller which I mentioned earlier, that is Atmega 328 based chipset, whether the 328 PU or PU variant. These are the variant PU and PU variant. This one is the microcontroller embedded into this development board. And further, what we do have is the Atmel is the manufacturer of these chipsets or the microcontroller, the EEPROMs microcontrollers, or we call it as EEPROMs, electronically erasable programmable memories. So in here in the Arduino, we do have is A type of connector, and we usually get the A to B type of data cable to connect it to the computer. So B type, usually you know that USB 2.0 is the B type connector and A type is this one. So through this we can able to connect it to our computer to further establish the communication in between. And apart from this microcontroller in mid between, what we do have is the bridge IC. Bridge IC is this one to establish the communication between the microcontroller and the computer system. We need to have this IC in between. So this one is the bridge IC, and just next to it we do have one crystal type of stuff, one shiny metal type of stuff, that is known as crystal oscillator. That is our crystal oscillator, because as a human being we have to keep track of the time, right? So we in general life we always use these watches or mobile phone to keep track of the time. And inside of that mobile phone and the watch itself, what we do have is the crystal oscillator, which is actually oscillating at certain frequency. So this one in here, it does have 16 megahertz frequency of oscillation. So means that much of oscillation can be counted to take 1 second as a reference or 2 second as a equivalent reference. So that is why we do have crystal oscillator embedded into the microcontroller to give the controller a sense of time. Then only now it will execute the exact amount of amount of like it can only produce the output and take the inputs at exactly the same amount of time, right? And how the microcontroller or the embedded system, the complete development board is taking care of that using the crystal oscillator. And here what we do have is the 7805 regulator, 7805 transistor or regulator, because sometime to power up our Arduino board, what we do have method is to utilize this port or this port. Otherwise, what we do have is this pin, this V in pin. Through three mediums, we can able to power up our development board, right? So suppose if we are supplying the power from our computer device, that is to point one, we won't require any of the conversion in between, because our microcontroller will take directly 5 volt from this USB port, right? But in case if you are utilizing this particular port on pin 2, on the 2 section, means we are utilizing a DC power source like the adapter or something like that. So to utilize the adapter or anything in between, the adapter does come with a value of 12 volt or something like that, right? So we need the conversion of voltage in between. So here comes the use of this 7805 regulator. And if I draw the circuit diagram for 7805 regulator or transistor, you will find the same circuit is present on the Google search as well. So this one is our output side, this one is our output side, and left hand side is our input size. So from the input size, we can able to feed up above 5 volt to 24 volt DC, and further all the time it will convert the value back to 5 volt for our use in different applications. So 7805 regulator can be used to reduce the voltage to a certain extent, like the 5 volt itself, for the microcontroller to utilize or get the power from. So even though we are supplying the 12 volt from the DC adapter or the jack system itself, it is actually converting the 12 volt to 5 volt, and further 5 volt will be granted to the microcontroller itself. And third method is to utilize the V in pin. Third method is to utilize the V in pin, and through the V in pin also we can able to provide the power like above 5 volt to 12 volt of input to this pin. And those things, because you will ask me a question, sir, in batteries and in power adapter, we always consider two of the terminals, like the positive terminals and the negative terminals, but you are talking about one of the pin only. What about the other? So whenever we talk about the 5 volt, 12 volt in V in pin or something like that, we are talking about the positive voltage, because negative always gets connected with the common pin, that is our GND. Two of the GND are there in this section as well. You will find one of the GND in this particular section. So GND actually signifies the negative input voltage, okay, the grounds pin in details. So after this, in Arduino board itself, we will find this section as completely the power section. This one is the power section. And on the left hand side as well, this section from here to here, this section is known as analog input section or analog input pins. So through these pins, we can only take the inputs in the analog form. Even though, yes, sometime I tried like doing the experiment with the digital input as well in these pins. Yes, it works perfectly, but it is only for the analog input section. And in analog input section, you will notice that A4 and A5 is actually marked with SDA and SCL. So SCL stands for the clock speed or something like that, and SDA represents the data pin. So for the I2C connection to control more than the number of pins available on the Arduino boards, we should utilize the SDA and SDA pin to integrate it with our I2C device to power up. Like suppose if you have to send some of the data to your LED modules or OLED display or any of the display, then you should utilize the SDA and SCL pins for the same. And apart from this, similar to other microcontroller, we do have the reset button on board, mounted on board, and also these pins. Okay. Just below the reset pin, we will find 6 of the pins floating here, right? And 6 of the portion are clearly blank in there. These are known as ICSP pin, which are used as programmers. So suppose if you have to like bridge other microcontroller whose USB port is broken or damaged, then what we can do, we can integrate it with our ICSP pin, or you can utilize the TX or RX pin for the same communication with other microcontroller, which are not capable to directly get connected with the computer system. So apart from this, what we do have on the right hand side is pin, the 0 to 13 pin, or we can call it as digital, we won't call it as digital pins, but IO pins in total. So these IO pins are nothing but input and output pins for our sensor devices and for our output devices. Okay, so in some of the pins you will notice, you will notice that some of the pin does have some of the symbols in front of it, like the pin number 11 does have this symbol in front of it, and 10 also does have this symbol in top in front of it, right? But in 987 does not have that symbol, 65 does have, and 3 does have. So what is the meaning of this particular symbol? So this pin symbol is nothing but to represent the PWM pins, and PWM stands for pulse width modulation. Pulse width modulation means, see, we seen all of the pins. These pins can be used to control the digital input and output, and these pins are responsible for the analog input only input, not the output. So the PWM pins or the pulse width modulation pins are actually responsible to generate the analog output. Means if we have to generate the analog output, then we should utilize these pins with the PWM symbols in front of it. Otherwise, the other pins won't support the analog output procedure. So we understood the two of the terms while utilizing the analog and digital system on our last class, that analog system does require the range between 0 and 1, right? Even though to take the inputs and also to produce the output. And suppose if we are controlling any of the car using the concept of our programming, then we should control the speed of car using the analog function or the analog write command. So the analog write command will work on PWM pins, and you should take care of this while doing the programming. Otherwise, you will stuck in the position where your program is not working or behaving properly, and you will be dumbfounded to get the details why it is not working properly. So these will be a common reason for the problem in between the integration of hardware components. So earlier I explained you the node MCU. The node MCU does have this microcontroller embedded into it, that is ESP8266 boards. Okay, so this, the size of this one is only the microcontroller, but apart from this, we had on our node MCU board is the development board. You can see clearly the difference between the node MCU development board, as it contains more than more things compared to the normal microcontroller. And if we take out the microcontroller from the Arduino itself, like this IC from this board, then we will see the similarities between the microcontroller and the development board. So what we do have else with is the Raspberry Pi system. So Raspberry Pi system does not falls into the category of microcontroller, but we call this system as microprocessor based system. So why to call this system as microprocessor based system? Because we are talking about the higher speed of calculation, more storage size, more processing speed, and so many other aspects to make it as a functional computer or mini computer in general. Okay, but these computer as well, these mini computer, we can call it as mini computer, does have some of the things integrated into it. That is why we are utilizing the Raspberry Pi in our development process. So we do have the LCD mounting bracket or the audio mounting bracket. So we do have the audio jack in here. So we do have micro USB cable. We do have power section in here. And also we do have these pins. These pins are known as GPIO pins for the Raspberry to like accommodate any of the sensor or the output devices directly into the microcontroller, and through the micro processor, the Raspberry Pi system, we can actually execute the entire artificial intelligence based or neural network based programs. Because if we do have the operating system which supports direct execution of input and output through the pins given into the board itself, then yes, we can control the parameters as well, right, to take the input and provide the outputs. So apart from this, we do have USB jacks as well on board mounted on the Raspberry Pi system. We do have LAN connectors to help the board get connected with the internet. But apart from this connectivity option, Raspberry Pi does have more options to go with. It does have Bluetooth functionality inbuilt. It does have Wi-Fi functionality inbuilt into the board itself, and like the other computers we often find in any of the places. So Bluetooth capability, Wi-Fi capability, and to have a complete operating system in which we can run the Python IDE and to execute the Python program directly on the screen itself gives a like best result choosing this microcontroller or microprocessor for our application. So in case if you are willing to go for the artificial intelligence or neural network based something like machine learning algorithm or anything like OpenCV algorithm, if you want to implement, then you should use the Raspberry Pi system for your application. So, okay. So now let's focus on the Arduino IDE. In our last class, we discussed what is IDE and how we can start writing the codes and upload the code to the board to see these things in action, right? So Arduino IDE is one of the open source platform for writing codes and uploading it to the Arduino board. It runs on different operating system based on what operating system you do have, like Windows, Mac, and Linux. So you can utilize any of the environment to accommodate the same. So this particular environment is written in Java and based on processing and other open source software. So window installer is very easy to install. So once you have to go through the arduino.cc. Let me open up this real quick for you. So in this page you will find the software option. Just go through the software option. The time you click on the software option, you will find the latest version of this release, right? The Arduino IDE 2.2.1. So, but as a new programmer, I would request to stick with the older programming versions, IDE versions. That is our 1.8.19. That is the much stable version compared to the newer version of Arduino. And also in this particular in this particular IDE, the version of this particular IDE, you can configure everything manually. You don't have to automate the process using the compiler or using the IDE development environment. So you have to do everything manually. That is why you will learn more while utilizing the older version compared to the newer version. So I recommend to start with the 1.8.19 version. So if I move back to the lesson, if I go back to the lesson, okay. So if I go back to this lesson, then you will find a general method, general way to install the application. Okay, sorry. So let me go full screen. Sorry. Okay, so you will find the time when you download the application from the open source website of the Arduino itself, that is www.arduino.cc. You will find these general agreements. So you have to agree, and further you have to click if any of the checkbox is unchecked, then please check it on, and further click on next, and further browse for the location of your installation and click on install. So the time you click on install, it will extract every file on your computer and it will show you a completed command on the screen itself. So you have to close this thing up and the Arduino is properly installed. So the time you open up the Arduino, as I already explained in my last class, so you will find some of the things, that is the menu bar, sub menu bar, and the sketch box in which you have to write the sketch. So the setup and loop function will come on a common basis by default in each and every new program. So further, let's start writing a code. Normally to see the hello world things printed on on the screen itself. So I explained you some of the things last time. Let me open up my Arduino IDE. So then only I can able to show you the new part. Okay. So I'm opening a new project. I'm closing the IDE. I'm opening a new project. Let me share my screen for the Arduino as well. So I opened the new part, and you will find I already explained how to set up everything. Like if you do have the board, Nano or Arduino, then you have to choose the board from the drop-down menu under the tools. So under the tools menu, you will find different boards are there. So you have to choose the Arduino, and further you have to select a proper port for your board. Right now, no port is visible in this computer because hardware device is not connected with the system itself. So what I will do, I will plug in the microcontroller, and also I'm going to plug in to my computer. So let's see what is the change after connecting the microcontroller. The time when you plug in the microcontroller, the port option will be clearly visible to all of you. So I have to select the COM port 18, that is the communication port. So now I'm ready to upload the program in my microcontroller, and you can see one of the LED blink program which I already uploaded, helping this LED to blink, because this particular LED is the onboard LED. Onboard LED. So we are going to control the onboard LED first, as we done in the last class, and further we will process with the other programs to integrate other hardware devices in the programming environment itself. So I'm going to integrate the LED directly with the port and board, so you can see the response of LED directly in your screen. So let me switch back my program. Okay, so I have to turn off the camera from here and have to use the live cam, so that choose the virtual background, none, close. So I hope my screen is visible. Yes. So now the board is clearly visible. Let me put something on the back side of this Arduino. Now it can stay as it is. So now if you look closely, the LED is blinking. So under this setup program, what I asked you to write earlier is the pin mode. And why to write the pin mode? Because we have to address individual pins. Individual pins means what? So suppose if we are focusing on taking the input from any of the pins, or taking the like producing the output to any of the pins, so we must acknowledge those condition to our board first, then only our board will understand that this particular input device is connected with our board. Or if the input device is something like a sensor, some sort of sensor like a IR sensor or something, then we have to declare those input parameters under the loop section. So setup will be composed of the pin configuration. Setup will run once every time whenever you turn on your microcontroller. So it will remind the microcontroller that this particular pin is going to be used as output or input condition, and further you have to process the data accordingly. So I'm going to write the output for the pin number 13, and right now we can see the output generation directly in our practical setup, right, in the Arduino board itself. But suppose if we are unable to get those response, suppose my LED is not working, or LED is faulty or something like that, then what we will do, we will implement this serial.begin function on the setup section to take the readings back, or readings to like acknowledge the feedback loop from the microcontroller. That time our microcontroller will further communicate with our IDE and inform us whether our program is executing properly or not. So under the tools section, you will find several examples, several buttons. That is one of the feature we are going to see is the serial monitor. For now, you can see there is nothing is coming in the serial monitor function. If you click on 9600, then nothing is coming in our serial monitor. But the time we will write the program like digital write, and pin number 13 should be high for first time, and we will put some delay to like limit the first line, that is our digital write. So we will again digital write the value to pin number 13, low value to the pin number 13, and it will insert some of the delay in between to hold that position for 1 second. As I mentioned earlier, the delay means we are talking about the time in milliseconds. Okay, milliseconds. And if we use delay microseconds, then we are talking about microseconds. Okay. So right now we are using the delay as millisecond. That is why I inserted 1000 in between. So 1000 is actually representing 1 second of time. So what it is doing is like turning the LED from because of this line and holding that position for 1 second because of this line. And on the 11th line, we can see we are writing the value of low to our LED, and further we are limiting, we are holding the value of low because of this delay line. Okay, so right now, if I check once again, the board is properly selected, that is Arduino, and also the COM port is properly selected. So now it's time to upload the code. So you don't have to worry about the uploading of code, uploading the code before compiling it, because the time you click on the upload button, it will compile. You can see on the left hand side, left and bottom side taskbar, that it is compiling this case. So whenever you hit on the upload button, it will compile the program first, then only it will upload the program to the board. If program does have some of the problems, suppose if I remove this semicolon from here, then now if I try to upload the program, then what will happen? Let's see. So it won't, the Arduino IDE or any of the compiler does have, the embedded compiler only does have inbuilt functionality. Suppose if the program is faulty or does have some of the error, then it won't upload the program to your board. Otherwise, what will happen? Your board will stuck on forever loop, because it is not going to execute the last command, right? So until and unless your program is error free, the compiler won't allow it to upload on the board itself. Okay. So now if I corrected the program, it is uploading it properly, right? So let me head back to the LMS portal. Okay. So, okay. So now, before heading to the LMS portal, let me write down the things necessary for the serial communication. So I wrote the serial.begin function. To help the computer stabilize the communication with my microcontroller at 9600 bits per second. That is the communication speed with my computer. So Arduino board does have limitation of communication speed, but apart from the Arduino board, if we talk in terms of, if we talk about the Node MCU and other does utilizes 11,5,200 bits per second to communicate with the computer system. Even though for the Arduino board, we can increase that value, but that is somehow limited for now. To see the actual result on a screen, even though if I click on the serial monitor now, I won't see anything coming in the serial monitor, because our controller is not actually responding back to our computer to establish a communication and give the feedback whether the input and output device connected to the microcontroller or executing the task properly or not. So that is the main problem with the programming part for now, but we will resolve that using the serial.print function. So I'm going to write serial.print function, and obviously serial.print function is going to write down the value. So under code, if I write down the LED is on, if I close the box, and if I do the same for the second digital write, that is serial.print function, I will write down the serial.print function. Sorry. And here I will write down LED is off. And if I close it using the round bracket and semicolon signifies the end of the condition, end of line, right? So end of the statement or end of the line. So whenever we have to like this sentence is properly declared, then we have to end this with semicolon in the programming part itself. So the LED is off. let's upload this program to our microcontroller and further check with the serial monitor whether our thing is working properly or giving us a feedback of LEDs on or LEDs off or not. So if I click on the serial monitor, if I click on nothing, then what is happening? Yes, we are getting the response. The LED is on, LED is off, LED is on, LED is off. But there is one problem. Each and everything is now printing on the same line, right? So we have to change the line. So to change the line after serial dot print, we just have to write down the ln word. So serial dot print ln, which help us serial dot print ln will help us to change the line. Okay, change the line. So if we upload the program now, let me upload the program to our microcontroller and further see what is the difference between the serial.print function and serial.println function for the same. So now the program is uploaded. If I click on serial monitor, then you can see the difference between the serial.print function and serial.println function. So the LED is on, LED is off, LED is on, LED is off. The same time the LED is turning on, the serial monitor is giving us the response from the microcontroller. Microcontroller is like communicating with our computer in real time. There is no gap of, there is no lags uh, behind the data transmission between the microcontroller and computer system. So through this, and I will request to each and every teachers out there to implement this in each and every programming you will do for the embedded system, because it is crucial for us to track the feedback, get the feedback from the microcontroller, because sometime right now we are only utilizing the LED in between, right? But in future, suppose if you are utilizing 4 or 5 sensor and 5 output device, and somehow your project is not working, means you will be dumbfounded by this situation. What is happening, what is actually happening with the microcontroller, and you will ask for help to each and every person. So make sure to utilize the serial.print function to like go for the debugging part, where you can see whether your program is actually executing or not, or if you do have some of the problem with the electronic components or the sensor or the output devices. Okay, so I hope the concept is clear for the serial.print function. Okay, so let's go for the same. Let's do some of the sample programming today and understand the concept of integration of different input and output devices. But before going to that, I would love to share my insights for some of the theoretical aspects that is very crucial for you. So let me share my screen back for the LMS. Okay, in mid between, I would love to ask one question from you teachers out there, that have you received the access for LMS? Have you got the credential from the team side for the LMS system, the learning management system? If you want me
Sorry,
to.
sir, I have not checked my mail as of now.
Okay.
I'll check it. I think so. Mostly it comes via mail only.
Yeah, it is communicated by mail only. So today's invitation, the same mail, I believe you do have your login credentials and everything. So if anyone from the teacher side does have, will find any difficulties like going through the LMS, then please help me with one message in WhatsApp or something similar to sort out the problem in time. So each and everything, whichever the things which I'm teaching you in this classroom program is properly logged in the LMS portal, and you can do those operations and other like experimentation with the codes and everything by your own in your free time. So today we are going to understand the arithmetic operators as well as different conditions in the embedded C++. We will go through the arithmetic operate variables and operators and comparison of rational operators, and we will see some of the cool programs to control the input and output devices. So what is exactly the arithmetic operators and why we need to have the arithmetic operators? So remember, whenever you are writing any of the conditions in your program, suppose you are using the operators like plus, minus, multiplication symbol or division symbol or the remainder symbol, that is percentage, then you should make sure that one space is there in between the words and the operator. So always use the space before and after the operator in your programming environment. Okay. So addition, if we have to write down the addition, and why we need to have the arithmetic operators, because Arduino IDE is capable of doing some arithmetic operation, and obviously to do the arithmetic operation we need the arithmetic operator for basic mathematical operations. So to do the addition, the operator is addition, the operator symbol is plus, which is available in your keyboard, and the example is A is equal to B plus 2017. A subtraction is same, the symbol subtraction, and B will equal to 2017 minus A. You will notice that in between the equal to and to, there is one space, always a one space between the operators. So you make sure whenever you are using any operators, you should give one space. Otherwise, there is no issue without giving the space between the operators. Sometimes it works fine, but sometimes it will cause you a problem in your programming, and it will throw an error in the programming part. So to do utilize different operators, for multiplication we will use the star symbol, for division we will use the backslash, and remainder we will use the percentage symbol in the picture itself. So let's do this particular programming to see the things in action. Even though we are not going to upload anything in our Arduino, but let's do this particular programming. I'm just copying this thing up and inserting this in my, inserting those things in my Arduino IDE. So I'm compiling this sketch. I'm compiling this sketch. So if we click on tools, if we click on tools and we click on monitor, okay, for now, let's upload this program to the Arduino. Okay. Okay, so you can see there is nothing happening in the microcontroller, but yes, we are testing. We are just testing our concept of different arithmetic operation using the same. So addition of the number 1 and number 2 is 18. Right now, we did not fed any of the things to take the input from the microcontroller or from the serial monitor itself, right? Just we are giving one of the value, that is int. We are initializing the number 1 as 15, and we are initializing the number 2 as 3, and we are calling one of the integer value, that is sum, named as sum. So we are actually doing the operation by writing the sum is equal to num plus num1 plus num2 in here, and also utilizing the serial.print function to, okay, there is one aspect which I forgot to mention. Okay, let me revert the program back to the older one. Okay, so now if you look closely to the line number 10, the serial.println function, the LED is on, right? So if we have to print the exact value of certain things, print the exact value of certain things, like the exact data is being displayed on the serial monitor, right? And suppose if we have to print out the value of any of the variables present in the program itself, then we won't utilize undercode in between. We will remove the undercode and we will directly write down the name of that variable, and I will show you the example in a minute how to do that. Okay, let me go back to the let me go back to the LMS portal. Okay, this will be your assignment program to complete and check the program by your own and see the result in your serial monitor, whether your serial monitor is giving you the same result. So, and also to do the subtraction, the same things will be followed, num1 minus num2, and for the multiplication, num1 star num2, and you will always find some of the one of the space is always given in between the operators to make the program functional without any error. And also to do the division part, num1 divided will by num2, the symbol for backslash. And for serial monitor function for float, okay, So float is the data type of the variable to store the result. We get the result, we get the correct result. So here you can see we are calling initializing the integer value of num1 and we are addressing it as 6. And second, we are calling the second value num2, we are calling it as 5. And float will be our result. So float will be anything or any data type or the variable to store the result. So here we are actually, you can see, if I copy this program from here and share the screen back my normal window, if I replace the program and upload the program to my microcontroller, yeah, the program is uploaded and there will be no response from the microcontroller side. But if I open up the serial monitor, then you can see the division of number 1 and number 2 is 1.20. The same thing I mentioned earlier now, the serial.print function will be used to print both of the things, whether the fixed values or fixed name and other details like the things mentioned in undercode. And also if we have to print out the floating values or the variable values, we will just use the name of that variable inside of the bracket and it will print out the value to the same. So if I share my entire screen, because the serial monitor is not visible in here. So if I share my entire screen with you, you can see the last line, the division of number 1 and number 2 is 1.20, and addition of number 1 and number 2 is 18 was the last program we executed. So division of number 1 and number 2 is coming from the first line of the serial print, that is this one, which is undercode, and it is printing as it is. But if we look closely to the second line, the after the number is 1.20, and there is no such places of 1.20 is mentioned properly, right, apart from the result itself. So if we look closely, what we are doing in the seventh line is we are gonna generating the result from by dividing the number 1 upon by number 2, number 1 by number 2, right? So we are getting that result by dividing these two values, and that result will be directly published in our serial monitor using the result function. Okay, let me show you the last program which we had done for the, yes, which we had done for the our LED blink one. So I believe that time also the serial monitor was not visible to all of you, right? Okay, so I uploaded the LED code, the code we had done for the LED. If I open up the serial monitor, then you can see the LED is actually, the serial monitor is actually giving us the response whether the LED is on or LED is off, right? So we will get the details in very less time compared to the normal communication. So LED is turning on and off the same. Okay, fine. Let me go back to the LMS, yes. And the remainder will be, we can utilize the remainder part by using the percentage mark in between. So you can do those experiment by your own in your compiler and see the response. Then only you will understand how to like go for the addition, go for the subtraction, multiplication and division and remainder part. So let's see the operator, the embedded C++ operators. So why we need to have the operators? First of all, the most of the common question to ask, like, so basically a variable is used to store a value or information so that we can refer. We know the constant and the variable things in our day-to-day life, right? The constant part is the constant value itself, which cannot be changed in point of time, right? But the variables keeps changing based on the inputs or based on the calculation we are doing in our programming environment. So variable is used to store a value or information so that we can refer to or manipulate it at later stage during the life of Arduino case. So memory is set aside for storing the variable, and the variable is given a name which allow us to access it in this case. So you can see different type of variables present in the Arduino sketches. So CHAR, the data type is char, which represents the character, and the size of the data type char in bytes is 1 byte. So it stores the 8-bit numerical ASCII value of characters like alphabet, symbols, etc. It can also store a signed number that is range of -128 to positive 127. So character literals are written in single quotes. Like if we have to write any characters or something like that, we will write it in a single quote, or and their ASCII numerical is stored in corresponding variable location. So we do have unsigned character or unsigned char, which does have size of 1 byte, and it can also be used to store the 8-bit numerical ASCII values of characters, symbols, etc. So int is one of the integer type. Data type is integer or int, and it can store 2 bytes of it can take 2 bytes of size to be stored. So 16 bits are there. Obviously, one byte is like taking care of 8 bits. So obviously, we are talking, if we are talking about the 2 byte value, then we are talking about the 16-bit values, right? So signed integer value that is in range of -32,768 to 32,767. Okay. So unsigned int also takes these 2 bytes of space, and it stores an unsigned integer value of 2 bytes, ranges from 0 to 65 65536. So difference between the unsigned int and int is the int stores the value between the negative of 32,000 to positive of 32,000, but unsigned int only deals with the positive counterpart of the integer value. And long is one of the type of data type which can store the 4 byte of size 4 byte of size of the data, and store up to 4 byte, means 32-bit data can be stored using the long value. And the range of this thing is from -2147,483,6482 to 147 up to 647. And unsigned long, similar to the same condition for unsigned int, unsigned long can be used to store only positive side of the integer value. Okay, ranges from 0 to 4, 294, 967, 295. So float is one of the one of the data type which can be used to store 4 bytes of data. And it also, like 4 byte of data means we are talking about 32-bit system, and you can see the range of it more than the more than the in comparison with other data types. And also we do have double data types which stores the 4 bytes, and float same as float. So defining a variable, so how we can able to define a variable or variable data type. So variable data type can be defined using the int or float depending on the type of variable you want, and variable name is the name of the variable in this data type. So let me show you one of the example to understand the exact terms in here. So suppose if we take the example of this code, so what we do have, this particular code is designed to print the number of times for which the loop function has run. Okay, so we are calling one of the variable that is int, and we named it as count. So we are storing the data in count. So under the setup function, what we are going to do is to call the serial print function, serial.begin function, to establish the serial communication between our computer and our microcontroller. And under the loop means we are talking about one of the place where we can run the entire program on continuous node. Okay, on continuous node. So if we replace this program and try to upload our program, so under the loop, what we wrote, count will be always equal, count will be equal to, not always equal to, it will be like sum up of count plus 1. So one count will be addition of the previous value of count a variable. So the loop has been executed. The serial print function in here will declare the first line that loop has been executed, and it will take the value directly from the variable that is our count from the section, and it will print the variable count. And after that also what we wrote in here, the serial dot print ln and times. And if we click on the serial monitor, let's see what is actually generating. So loop has executed 1 times, 2 times, 3 times, 4 times, and so on. It will go on and on for an infinite number of times. So we are starting from the count from 0. That is why it is starting from 0. So if we try to place 50 in here, so if we try to place 50 in here, okay, so 50 in here, and try to upload the code to our microcontroller. Okay, so if we try to upload the code to microcontroller and check on the serial monitor for the same. So because earlier we stored the value of count, the 50 value to the count variable, that is why the loop keeps on executing the function count is equal to count plus 1, means the second value will be printed as plus 1 all the times. So it is executing the time, executing the program similar to our previous function. So I'm reversing the program now and uploading the back to the LED function. So you will see this type of execution from your program. So the float is something in which we can store new variables. So, okay, the float here we defined the float num and float num2 for the same, and also called one of the place where we are going to store the data, that is the result section. And result section, how we are getting the result? So first we declared the serial dot begin 9600 to establish the serial communication, and further we wrote the first number is, and we directly printed the value of num1. And second, we again called the serial dot print function to write down the second number is, and directly we called this num1 in this segment. Okay, there is one error in this program. Let me copy this thing up and paste it in here. So yes, the problem is there. It does not have to be num1, because num1 is already printed on the first line. So there will be num2 on the 10th line. So here the result will be num1 plus num2, and further the serial print function will help us with the data. The sum with 2-digit precision is this, the result, and second the result comma 5-digit precision. So we are actually writing the precision using this program. So if I click on the serial monitor and open up the serial monitor, you can see the exact output coming from the system itself. So first number is 10.00, and second number is 5.52. Sum with 2-digit precision is 15.53, and sum with 5-digit precision is 15.52857. So print out the values up to the digit. What we need to do, we have to like insert one of the comma and write down the number of digit to be displayed in the serial dot print function. Then only it will display the complete number in total. Okay, so if we go back to the Arduino, okay, let me, okay, fine. So if I go back to the LMS, you will find the same things mentioned in here properly, right? So comparison or the rational operator, what is comparison and rational operator? So obviously the rational operator is an operator that tests a relation between two entities. The relation of a rational operator is either true or false, means what we are going to do is to compare. That is why we do have the rational operator. So we do have different method to compare the things in the programming environment. But before proceeding with that, we have to understand, we are talking about some of the key aspect in Arduino programming, right? So key aspect means, so we are controlling the digital system and analog system using our input and output pins, right? So in digital system, we do have 0, 1, and in analog, we do have 0 to 1, right? So 0 in here is actually representing the off condition or off state of our pins, right? So one representing the on condition, and in programming we write the on condition as high and off condition as low. So the 1 and 2 value is something like that. True is represented by 1 and false is represented by 0. So let's see some of the 6 relational operator to go for the same. So less than, for less than we will use sorry, for the greater than we will use this operator symbol, and here is the example in front of you. Current year is greater than 2015. So less than will be represented by this symbol, and 2015 is less than the current year. Greater or equal to will be represented by this symbol, and you can see the example in here. And less than equal to will be represented by this symbol, and here is the example. And equal to will be represented by double equal symbol, and the example is on the right side. And not equal to will be represented by exclaim mark and one equal to, and here we do have the example for the same. So you have to follow the same operator, rational operator in your programming logic to perform the different tasks, and all like the similar setup. If you go through the LMS portal, you will find these programs are clearly logged into the LMS system. So you can copy this program and further test out the program as per your availability to test out. So you can see we called the one of the integer, that is the variable. We initialize, we call the integer variable, that is result1. This one is the name. We can call the result1, or we can change to any of the things like dragon or anything of your choice to perform the same. So we wrote, we called two of the variables named result1 and result2, and further under this setup function, what we are doing, for the new person who are doing the program, I always recommend to go for the serial.begin function to see the things in action on your serial monitor. And further we compared the result1 and result2. So result1 is equal to 7 greater than 4, and result2 equal to 7 greater than 10. So what we had done in here, we called these two operator. Actually, we are storing the data whether 7 is greater than 4 and 7 is greater than 10 to directly to the result1 and result2. So serial.print function will first print out the hard-coded values, like is 7 greater than 4 will be printed as it is in our serial monitor. Okay, let me copy this thing up. Let me copy this thing up in my program window in the IDE itself and upload the program to my microcontroller. So if I upload the program to my microcontroller, then you will find the things communication from the serial monitor. Let me click the serial monitor again. Yeah. So is 7 greater than 4? So we printed the value 1. And is 7 greater than 10? We printed the value 0. So operator can be used to determine whether the value is coming as true or false, whether the value is coming true or false. So 7 greater than 10. So that is 0, printed 0. So 7 is not greater than 10. That is why the value is printed 0 in here. And we just asked the system whether it is okay or not, and system responded with the same configuration, that 7 greater than 4, then yes, it is printing the value 1, and we will know that value 1 represents the on condition or the high condition, right? Means okay, yes, true condition. So that is why we got the value 1. So first line is actually getting printed as it is, and second one is the value which we stored the value earlier in this section by taking the consideration of two comparisons. And the last line is printing the value of result2. So we did not utilize any print ln function on line number 10 and line number 8, because we want this 8 and 9 line to be the same in the same line. 8 and 9 section of this program to be in the same line, and 9 11 and 10th will be on the same line. So that is why we done the comparison. Okay, let's go back and less than. Yes, you can go through the entire programming concepts mentioned in the LMS portal and let me know if you find any difficulties so that I will cover up those things in my next class. And further, let's test some of the sample program as we learn some of the things. The LED blinking program were already explained, right? So, okay. So LED blinking program in which we utilize the pin number 13. So even though if we remove the pin number 13 in here and we will write in build underscore LED, then it should work. Let me check once. Let me check once this program. Let me check this program. Yeah. And inbuilt LED is not the internal program. Okay. So inbuilt LED function. So let me search it. Onboard LED underscore built-in. Okay, fine. So I'm going back LED underscore control X and LED underscore built-in. So built-in. Yeah, this one is the inbuilt function for the Arduino. That time the line were not turned blue, right? And this time, the time when I mentioned LED underscore built in, and you can see this thing came up with blue color, right? So whenever blue color coming up in your programming environment means we are talking about that we are calling some of the inbuilt function of the Arduino, right? And LED underscore built-in actually signifies the pin number 13 directly connected to our onboard LED, as I mentioned during the image, during the demonstration of Arduino Uno boards, right? And every board does have one of the LED inbuilt into the board itself. So if you do not have any LEDs or other device to test out the program, you can directly tweak with the same. But to call this particular setup either the LED underscore built-in or the pin number 13, we can do these things by other means as well by calling one of the variable, that is int LED is equal to pin number 13. And further, the place where we use the pin number, we don't have to use that. We just write the LED in the place of pin number 13 and the program will work perfectly without any problem. These are the methods to be implemented while programming the Arduino boards, because some of the times what will happen, suppose if you are writing the program for your car or something like that, and suddenly you changed your mind to replace that particular pin with the other pins, then what you will have to do, either you have to go for this search and find and replace with, or you have to do it manually for each and every place you mentioned the pin number. But through this method, if you call any of the variables, if you call any of the variables and directly assign the value to the variable, that is I'm calling the variable LED which to represent the pin number 13, right? So now it is much simpler for me to integrate the LED in any other pin. Suppose if I have to integrate the LED on pin number 10, then I only change the value on first line. I don't have to make modification in my remaining code. So this is how you can call different portion in the LED itself. And further, okay, the push button LED program is there to take the reading. So I will help you with that and we will conclude this session for today. And further, what you can do, you can go through the programming part by yourself and let me know if you find any difficulties with the programming part, so that in next class, I will cover up those things in details. And also, let me to have the status of the LMS access. You already got the direction or the credential to start with. So I'm going to replace this complete program with the program from the LMS. Okay. So I'm calling the pin mode and serial monitor to provide. And I configured the button pin as an input, and button pin you can see is connected to pin number 2 of Arduino, and LED is connected to pin number 13. So yes, that LED is similarly connected to pin number 13 and we don't have to make any modification. So what I will do, I will take out my breadboard and connect the pins to directly to my to the to the push button. So through that, we can able to control the LED using our push button, and further we'll control the movement. Okay. So now two of the push button is implemented. So I'm connecting one of the wire of push button to GND pin of my Arduino. GND pins, why? We always short one of the pin to GND pin. So either way, you can change the pins to any of the pins of your choice. Means if you want to give the high value directly to your micro through the push button, then you can directly connect the state of push button to positive side of the pin. So button pin is configured on pin 2, and further under the loop section, if you look closely, you will find the button state. We are storing the data into the button state, and actually to do so, as I already explained in my earlier classes, the digital read function can be implemented. So digital read function will take out the reading from the button pin, which is connected on pin number 2, and further we will go for the if statement to follow the same. So if I paste those program as well, so if button state is high, then what this program will do? This program will first write the value to the LED pin to high. And what is LED pin? Here we configured the LED pin to pin number 13. So the value, high value will be written to directly to this pin number 13, which is connected to our LED. And further, if it is not pressed, then what will happen? The digital pin will write the value to low value, means the LED won't glow. So this is the basic summary to like operate, take the inputs from the digital pins. So let me upload this program real quick and see the response in the serial monitor, because we configured the serial.begin 9600 for the serial communication, and also we are writing each and every values after the completion of our execution, program execution. So if I click on the serial monitor, so right now it is taking the state of directly taking this state from the LED. So suppose if I change the value from the 5 volt, then what will happen? See. So now if I click on press button, then the LED is actually turning off. And if I leave the button, then actually LED is turning on. So it is changing the state in between to follow the same, right? So test out different programs and different examples mentioned in the LMS portal, and further help me with your questions and summary for the same. In case if you find any difficulties regarding the program or the complete session, then let me know so that in next class I can able to cover those for you as well.
Thank you so much, sir. Just one query, sir.
Yes, ma'am.
Do we need this physical board, sir, for this? Because I don't have.
Yeah, the last time, ma'am, I already requested every teachers and every mentors out there to have these boards beforehand for the practical sessions, right?
Currently, I am in Qatar, so it's very difficult to get it out here.
Okay, I believe there will be some local outlets as well. There are some local outlets who buy these Arduino, because these Arduino boards are so common nowadays. You can buy it in any hobby store or something like that in Qatar.
Okay, I'll just check it out, sir.
Okay,
Thank you so much.
if you do not have the board, there is nothing to worry, because as I showed earlier that, okay, let me show you once again. You can join my, okay, I will share my classroom link today in the chat section.
Okay, sir.
Okay, I'm explaining this. Okay, I sent you the classroom link in the chat section. Further, you join in my Tinkercad profile. Through the Tinkercad profile, what we can do, we can directly design those things like circuitry, the things which I explained just now. Let me show you by doing it in here using the open source platform. That is why I keep mentioning the open source platform in your application. So if I bring the LED and if I take the wire, let me take the wire and connect this one is the cathode, right? So cathode will be connected to the negative GND, and anode will be connected to the positive pin. And further, if we click on the simulation button, then you can see the LED is perfectly showing us the example of LED blinking program. So you can integrate many sensors and other devices directly in this platform and come up to the idea whether your program is properly working or not. So we do have the code
Yes.
section as well in here. So the time you click on the code section, the text method will be should be chosen in here, and further you can write the program in this section to further execute this program. You can see the same program I showed you earlier is mentioned in here as well, right? So you can go for the Tinkercad platform for the execution of the programs before having these practical onboards to do the setup.
Yes, sir. I have already tried this last time you have given. So I have done this part. But the other programs which we have discussed with the operators and also we can also try here on
Yeah.
Tinkercad.
You can try it in here as well. You
By
can
that time I get the physical board.
Yeah. Till you are not, suppose you are not having any physical board, you can do the simulation. But let me send you one more platform in which you can see the serial monitor function as well. So I personally use that particular platform for my project development. That is WalkV platform, in which we do have these type of setup. So in this platform, you can exactly see the outcome of your program as well as the serial monitor stuff. I will send you those in the WhatsApp group, ma'am. Okay. This is all for today. I hope you understood and learned something
Thank you, sir. Thank you so much. Yes,
from
sir.
this session. So in next session, we will focus on practical projects and idea coverage, as well as we will discuss more about the open source platform like the Tinkercad and other platform for you teachers to perform the simulation and the project work before buying any of the hardware part from the market. So it will be helpful for you to cope up with the same. So thank you so much for the opportunity, and I'm handing this session over to that, sir. Thank you so much, sir, for the opportunity.
Yeah, thank you, Saurabh, sir, on that, and thanks everyone for joining this session. We are going to, I think, this time we arrange for in Sunday, so we are planning to arrange some survey kind of things because I got multiple messages they are not able to join because of their other commitment as well. Okay, and we will take a survey and then based on that available time we will arrange our third session over there, right? And apart from that, if you have any questions for our registration for to convert into our paid course as well, feel free to ask over there. We have answered almost all the questions that we received this entire week. Okay. If you have anything, just feel free to ask. We are here to help you out. Thank you. Thanks for joining this today's session. Bye for now.
Thank you, everyone. Good day, everyone.
Good day.
Okay, sir.